Okay, moving on to question 2. This is still a kinematic question, I think. We have a particle which moves in a straight line so that the position here is t meter from a fixed point. Okay, after t second is given by this equation. So I'm going to start by just define, probably not that. I don't think we have to sketch anything, so I'm just gonna define the position as x of t equals to 2 times t to the power of 3 plus 6 times t squared minus 18 times t plus 10. Okay, so this is the position in terms of time, the initial position of the particle. So the initial position is when t equals to 0, and what you simply need to do is sub in x of 0, and that's 10. So 10, there is really no meter. 10 meter is going to be the initial position of the particle. The initial velocity of the particle is part B. Now, to find the initial velocity, you need to first of all find velocity. And velocity, I'm going to define as velocity is the derivative of x of t. So we're going to define v of t. Let's assume v of t is velocity. The reason why it's already bolded is because I had another question. So it doesn't matter, you can over-define. Again, I keep doing this. It has to be in terms of t, of x of t. Okay, so v of t is now 6t squared plus 12t minus 18, and this is the derivative of x of t. To find the initial velocity, I just need to sub in 0. So negative 18 meter per second is going to be the initial velocity. Initial acceleration is the derivative of velocity. So if I want to find acceleration, I'm going to call it a of t, and it is going to be the derivative of v of t in terms of t. So acceleration is 12t plus 12. Just need to sub in t equal to 0. 12 meter per second is going to be the initial acceleration. When and where is the particle momentarily at rest? If particle is at rest, then velocity is 0. So when we talk about when the particle is at rest, the when is what t value, and where is position. So I'm going to solve v of t equals to 0, so that velocity is 0. You have two times at -3 and 1. Obviously, time has to be non-negative, so I'm going to pick t equal to 1 only, and then to find the position, simply sub in x of 1. In this particular case, the position is also 0 when velocity is 0. Find the acceleration when velocity is 0, so a of 1 is 24 meter per second. Find the time at which the object reaches or passes the fixed point O. So if the object passes origin, then x of t, which is the position, must equal to 0. So you just need to find the time. All I'm doing is solve for x of t equals to 0, solving for t. Once again, I have t equal to -5 and 1, and we need to eliminate the negative answers, so just 1. That is it for question 2.